teeny bit of background. I don't know how much they've told you about me. Hopefully nothing too threatening or bad. I work as a product design engineer. I've been doing it for the last 3 years now. I've worked for a few companies, including BlueStamp when I was right out of school. For the last 2 years, I've been working for a very small startup, which has been growing more and more and more every year that I'm there. But we make, we're technically a drone logistics company, but we do all of our own hardware in-house because no one else is making what we need currently. I work on that product side, so as a product design engineer, most of my work is in mechanical design, but I work very closely and do small projects within every single aspect of our company. So anything from industrial design to electrical engineering, software, business, a whole bunch of different things. Very similar to how you guys have full ownership over your very small projects. I work on a little slightly bigger team, but have ownership over all these very different entities and not pigeonholed into one small branch of engineering. But with that, the vast majority of my work is on the mechanical side. I've got a quick little video. This is actually on the front page of our website that I want to show you guys to kind of just give you an idea of what the products we make look like, and hopefully give you guys a sense of what it is. I'll go more into detail on what I do that relates to what you guys are seeing.
The sound might not work through the projector.
Oh, wow, that sounds great.
Do it up there. Can you guys hear that? So that's just a quick kind of little video. We primarily use that to generate business. We show that to almost every investor that comes in. It's more of like a product teaser. Actually, most of what you see here is the station on the lower half and then one of our drones on top. The station is a one-off, so it's only a single prototype. That station was completed about a year ago, and when I started 2 years ago, there was almost no station. It was just an exoskeleton. Myself and one other mechanical engineer completed this project about a year ago, and we've since then kind of grown. He focuses on the vehicle. I lead a small team of 2 other engineers that does all of our station development, along with an industrial designer who organizes the 3 of us. And I'll show you guys what that station has turned into. It's currently not available to any public use. So what we do as a company, I mentioned the drone and a station. We focus on logistics, so a lot of our work currently is being done in Switzerland. We fly between hospital networks. So right now, if you want to deliver blood from hospital A to hospital B, or lab samples, they use couriers. So people will hop in a car, basically a taxi, and take it between the facilities. Especially with something like healthcare, where you've got something like blood that needs to be kept at a certain temperature, that needs to be delivered quickly, promptly. You can't necessarily do that when you start running with couriers who cost millions of dollars, and also you're subject to traffic, more accidents. So we're starting to offer a service that we basically can cut down a lot of the logistical nightmare involved with transportation of small goods. So The current payload of our drones is about 2 kilograms, which is 5 pounds. That's not that much. There are definitely other drones out there that can carry a lot more. Eventually we'll probably build into a product suite that has some drones that can carry larger things, some that carry smaller things. We currently focus on kind of one vehicle. Also, before I go too much further, because I can just keep blathering for a while, if you guys have questions at any moment, I'd much rather answer your questions. So if I say something that sparks your interest, feel free to shoot a hand up, blurt it out if I'm going too quickly. I'd be happy to answer your guys' questions so that it makes a little bit more sense. Yeah, great.
Sorry. In the future, if you want to make this more for like commercial use, what's the idea of placing these stations? Like, what's the idea? Like, where are you going to place them? How frequent are they going to be in towns or cities? Like, what's the idea?
Cool, great. So our company name is Matternet. So to that point, what we really are focusing on is making a network. We have a number of other competitors, or even say take Amazon, who has this vision of, most of you probably have Amazon Prime or know someone who does, and it's great, 2 days later the box shows up, or even the next day, sometimes the same day. And they have this vision of, from their warehouses, shipping out drones that could land in your backyard, say, and set down a package and then move on. That's coming from a centralized distributed network. So with our vision, instead of having one major hub, we actually would envision putting a station as frequently as we can, and thus we're able to create a network. In that sense, even if you wanted to get package from point A to point C, you could stop at point B in the middle, change your battery, and then effectively get a longer range, be able to do shorter, smaller trips, have more locations where you're able to store things. It kind of, you decentralize the network that way and allow for a lot more interaction. So in that sense, right now, we currently don't have a viable station that we can put out in public. The one that you're seeing here, there's a lot of issues. So this rests, it's maybe about this tall. It doesn't have anywhere safe for the drone to stay. There's no hangar. And it's also within reach, so somebody could easily come up and get hit by the props, which spin about 10,000 RPM, so that'll definitely take off a finger or head or whatever it is. Get to you in one sec. So the idea for us is to, our next big thing, although we have drones that we're ready to mass produce, we really want a station that we can mass produce, because that's where all of a sudden we're able to really create that network effect. Although we're starting in healthcare because that's where a lot of money is, as Robin probably knows.
I don't. Don't look at me like that.
Healthcare is a great opportunity. They're already spending millions of dollars. We're able to offer a service that is better and cheaper. And then from there, we would look at maybe growing into something like e-commerce. You guys have probably seen Amazon lockers, things like that. So you can envision, hospital networks are great spots to start, but you could start growing onto campuses. You could start growing, a lot of big companies have huge campuses, universities, high schools, and then you can start, once you have proven yourself, a big amount of the work that we do is actually doing the regulations with the FAA, and also we work primarily, until recently, out of the country because regulators in other countries are a little bit more relaxed, so most of our work is in Switzerland. A big thing is writing the rules about when and where you can fly drones. We've seen a number of issues recently with drone pilots, people out there getting a cool shot on their vacation and running into airspace and hitting hospital helicopters or all kinds of other things. So there's a lot of rules that have to be put in place before it's really safe to fly. So we're helping write that rule book right now here in the US. We actually just got approval to run a couple programs down in San Diego and in North Carolina. So we'll start to see things open up here over the next few years, and who knows, 5 years from now, you might be able to walk down to your local grocery store and there's a station sitting outside and you can have a package delivered to you. But our focus on e-commerce is definitely secondary to trying to do healthcare first, use it a way to grow our company, validate this whole process of drone delivery as viable, and then continue to grow from there. Yeah?
How the
Yeah, good question. So we actually have gone through a number of iterations on how we communicate with the drone. There's actually a whole suite of different communication levels. As far as knowing where to land, the drone definitely has GPS. I don't know if you guys have ever tried using your GPS. I mean, driving around with your parents, you're getting directions, and sometimes if your Wi-Fi is not on or for whatever reason, the GPS kind of loses you. Even if you went to check your phone right now, your GPS might coordinate you within 5 meters if you're lucky. So GPS is good for getting general location, but imagine you're trying to land on top of a station, which is a 1 meter by 1 meter platform. You actually need to have much higher accuracy in knowing your positional location. So we've gone through a couple different things. Previously we've used infrared. Is anybody in here working on the tabletop robot? Or anybody working on a project with infrared? Yeah? Are you using it for distance sensing or anything like that? Motion? Cool, yeah. So you can detect motion, you can also use it, you can use infrared as a positional kind of feedback. So if you create an array, so this station actually has an array of infrared LEDs that send up a signal to the drone, and the drone has a receiver. So it can actually judge distance and actually positional location through infrared. That's not a great system for us because it's optical. So the problem with an optical sensor is weather. As soon as you add in rain, snow, any visual obstruction, you're not actually able to communicate. So if we went to land and it's raining, you might not be able to see the beacon where you're supposed to land on. Now you're relying upon a GPS, which is only going to put you within a certain area. If you land on the station on the side, the drone's going to tip over, crash, send things flying, props, blades. It's pretty dangerous. So what we're actually shifting to now, which we use primarily, is UWB, which stands for ultra wideband, and it's essentially radio frequency. So you can put about 4 sensors on a landing pad and 1 in the drone, and it's able to, by communicating with all of them simultaneously, locate its position. So that's kind of where we're going now. If that was too technical, let me know.
So if you don't have a camera, then how do you detect if you're going to hit something like a power line?
Good question. Yeah. So the other advantage of a network is we're able to actually pre-map all of our routes. So almost every route we ever fly, we've already looked at it. We can go to the location and say, okay, we're going from point A to point B. We know what the airspaces are in the area. We actually will plan our routes so they'll go over residential areas during the day and over industrial areas at night because of lower population. So you don't want to be flying over office space during the daytime, that's where everyone is, when you could be flying over neighborhoods that are less crowded. You don't want to send a drone flying over, say, a prison, for example, because it might get shot down or somebody might decide to throw something at it. There's all these little intricacies, but by having a network, you can pinpoint an exact route. So we'll actually plan ahead and go look at the location and know, okay, we're dealing with power lines here, we're dealing with construction, but it isn't perfect because things can change. You could have a crane that gets put up in the middle of your route overnight for working on a building. So in the future, and that's one thing that we are heavily working towards adding on, is sense and avoid technology. So you can do that through a number of ways, whether it's LiDAR, a camera. There are a couple competing technologies we're kind of waiting. That's not something, a lot of the technology we use in our company isn't something we develop ourselves necessarily. There are things we focus on, but for something such as sense and avoid, there's 20 other companies right now, especially with self-driving cars being such a huge thing that people are working on. There's 20 other companies at least that are working on sense and avoid, and that is technology that we would then buy and integrate into our drone, but we wouldn't put the power into it ourselves. Yeah.
So one of the big issues with drones is, short battery life, like averages like 9 minutes, 12 minutes tops. Then you also have speed on some of the lower end, which is 20, but if you go up to a DJI $1,000, that's like 40 miles per hour and 30 minutes of battery life. So what are the specs on your drone?
So our drone is very similar, but we have a much bigger drone. So we actually have 40 miles per hour is kind of cruising speed, and our battery lasts for about 40 minutes at that time. To do that, we manufacture our own batteries. So that's something that nobody else is doing. Nobody else is making a battery specific enough to what we need. So we actually put the work into making our own battery. On that end, a huge part of my job when I first started was making this vehicle as light as possible. And it's still nowhere near that, not until you go into mass production or start spending a lot of money to do carbon fiber parts, titanium parts, can you really drop that weight. But weight is actually a quadratic function as to how much battery you can get out of the drone. So if you can drop 5 pounds off of a 30-pound drone, you can almost double your battery life. So that's something that we spend a lot of time working on as well. Yeah.
How do you prevent like the drone being intercepted or security measures?
Yeah, that's a good question. You can't necessarily. So as far as interception goes, nobody could hijack into our system unless they actually hack our system. So we have our own cloud software that controls all of our assets, from the drones to the stations. So unless we directly got hacked, they couldn't take it over. What somebody could do, and what frequently happens, especially, you'll see this at large political gatherings where there's high priority targets. Police now have essentially jammers, so they can go in and jam signals going to drones, and that essentially would just crash the vehicle or trigger it in most circumstances. So say we lose contact with our drone or there's a failure in one of the props, we have a parachute built in that automatically triggers. So there's a number of fail safes that if anything goes wrong, it knows, oh shoot, I'm losing power, I've lost communication. If it just loses communication, it can teach itself, so it knows, okay, I can either try and go and land. We have programmed in kind of contingency landing spots. If it can't reach one of those and it's going to run out of battery, then it would shoot the parachute and we would have to do a recovery. But there's no way to fully prevent that at the moment. If it gets jammed, it can try, but you can jam a GPS signal, you can jam a lot of things, you can jam communication to the point where the drone's not going to know what to do at all, and in that case, it would trigger a failure termination system. Yeah?
Adding on to the idea of security, like at the pickup points where the packages themselves are picked up, how do you like ensure that the right person is leaving the package rather than
Yeah, so that's all done via QR codes. And I can maybe now show you a second video of what the station looks like. Well, you can see in this one too, so it shows a scanner right there. If you were to go and receive a package, you would actually take your phone, it would have your profile, it would tell you, hey, your package is ready, and it would show you a QR code, and you would go up, scan your phone with the QR code, and you would know, okay, this is so-and-so's package, and it would give you the package that belongs to you. So if you were a malicious target in our mind, and you wanted to go up, you would have to just take a baseball bat to this thing and break it apart. But as soon as you touch it, there's going to be all these alarms going off. It would be alerted to us, and we would have the police probably en route by the time you were able to break inside of the thing. But for the most part, yeah, it's all, by making our own cloud software, we're able to control the network on every aspect. And let me show you guys, let's see here. Well, quickly, okay, this is kind of clearly shown. This will give you guys a little bit of an idea before I show the next station. This is the software that I use for the most part. If any of you guys use SolidWorks or Fusion 360, okay, a few guys. So a lot of mechanical engineering is done in CAD, computer-aided design. This is Siemens NX, which is what who uses that? Tesla uses Cadia. Apple uses NX. There's a number of big names out there that use NX. It's a little bit more powerful. Lets you do some cool things. Synchronous modeling being one of them, which allows you to design a little bit more flexibly. But this is the program I use a lot to do a lot of, creating the parts, and then I work a lot with vendors also in manufacturing. If we can produce anything in-house, we have CNC, laser cutter, a few other tools that we kind of use to make parts in-house, but if there's something bigger, then we'll ship those out and have somebody else kind of make them for them, and I work with vendors closely on that. This is actually kind of the next generation of the station, and I can show you guys a quick, I'm in presentation mode, damn it. Anyone know how to get out of presentation mode? Actually, I want to see my desktop.
Oh,
Yeah?
Go to settings.
Huh?
Go to settings, and you want to just show exactly what's on your screen, right?
Yeah, I actually can't even see it on my screen because of
Oh, it's
Yeah.
just the displays.
Resolution.
Yeah, it's put onto that as opposed to the monitor.
Yeah, so the display.
Displays.
And then up to the top arrangement.
Should
and
be
then
able to
hit
hear.
mirror.
Yeah.
Yeah.
Is it better?
It's still not showing what's on
Because
it.
optimized for your computer. There.
It didn't kill the,
The extended display.
here, I'm gonna plug it back in and out
Yeah.
and see if I can get it to that presentation mode guide. Let's try that, okay, sweet, cool. There we go. So this is actually a video of, so I mentioned kind of that first video you guys saw is a station that we made as a one-off. We use that a lot to kind of validate our business proposal. This is what the station actually looks like now. So this is what I've been working on heavily for the last 4 months. You can see it's a lot taller. It's got this, the landing pad is up there, kind of at this surface. So the drone lands a lot higher, out of reach of people. And then there's room for all the batteries and payloads to be stored in this area. This is where a user would go and scan their phone. And then you can see a payload's actually it's coming out and being delivered to somebody. And that would go back up. Or you could be putting a payload into the system the same way. And then a lot of the electronics and kind of controls are housed in the lower part. Yeah.
How tall was that?
The full height, bottom comes up to about 6.5 feet, so the top of it is probably closer to like 9, 10 maybe. It's pretty big.
Yeah.
So I mean that was kind of one of our focuses, and I mean inevitably something fun about product design for me is we're constantly shifting and adapting. So anytime new technology comes out or we release a product, we'll test it, we'll do a lot of research on it, and we might find out, oh, it doesn't matter if it's close to the ground, or we might find out, oh, it's not high enough up. There's a lot of changes that are kind of constantly put into each iteration based upon what you learned during your research. So it would be like if you guys did BlueStamp, made one robot. As soon as you finish after 6 weeks, you decided, okay, now I'm going to make an exact similar robot with a few more features, knowing exactly what I knew from the one before. So we're constantly ripping, iterating. The vehicle that you guys saw up on top of the station, that's from about a year ago, and that was our version 7. We're currently now just starting to work on a version 9. So that includes a lot of the changes I talked about, moving from infrared to radio frequency. It includes different landing gear, different propulsion systems. So we're constantly kind of updating, making changes. Any other questions?
I have a question.
Go.
Yeah,
Yeah.
sorry. Are you guys allowed to see like what's inside the package when you deliver it, or when the person delivers it?
Oh, great
That's a
question.
good question. In theory, no. So, I mean, a big thing, a reason we also don't run cameras currently on our drones is privacy. So a few of our neighbors complain about noise and say, oh, they're up filming us, and then we simply say, well, we don't have cameras in our drones, so how could we film you? But it's another thing, you know, privacy is a big thing, especially in today's day and age. On that note, in theory, with the new system that we would be incorporating, if you had a station at point A and point B, one user is taking a package that they've set up, they would insert it into our station, it would go up. It's essentially locked. It's out of, you know, the hands of any other users, it's out of our hands. It would be loaded in a drone, delivered to the other station, and then whoever's supposed to be receiving it would come up, scan, and receive it. So in our system, we don't actually even have any of our employees involved. It's a fully autonomous network in that sense, where you don't want to have a worker at every single station that exists out there. That's what we currently have. So instead of having stations, we just have landing pads. So there's a landing pad on top of a roof in hospital and another at another hospital. The drone goes from A to B. One of our workers goes up and takes the payload out of the drone. So with a station, you can make it autonomous, you can take workers out of it. You can also add locks to payloads, different things. However, one thing to note for that is we would still have to have some knowledge of what's inside, because it'd be very easy for somebody to put a bomb, to transport illegal goods. So there is control on our end of being able to scan, being able to detect what package contents are to make sure that, you know, it's safe to transport. And also that even if the big thing we have to check is how heavy it is. Because if somebody decided to put in something that was too heavy, that was not 5 pounds, but was 10 pounds, the drone won't be able to make the flight that we thought it might be able to make. So we still have to have a fair amount of control while still giving, you know, our clients full privacy. All right.
Awesome, thank you so much.
I definitely had a question.
Okay. Ooh, last question.
Three questions. None of which are relevant. Okay. A, I want to know what you did Saturday morning at 7 a.m. B, I want to know why you went from dressing like a good BlueStamp member to now wearing t-shirts and a short and weaving a Palo Alto, California story there. And then last question, 2 parts, so 4. I want to know a reflection of your time as lead instructor at BlueStamp in 2015? 16? 15? 15.
15.
Yeah, 15. And then D, what quick advice you give to, hypothetically, a 3-day-old BlueStamp student?
3 days old. This is your first week?
Yep.
Wow. All right. Just finished start part. All right. Let's back all the way up. So 7 a.m. Saturday, I was doing Barry's boot camp with that guy.
Yeah. Fred's a real man.
It took me about 3 years to get there. That was part of it. You know, Rob reached out, asked me to speak. I said, hey, we should probably do Barry's. And I'm still a little bit sore, so I'm regretting it, but not really. It was worth it.
Yeah.
My roommates weren't too happy because I got home at 8 a.m. while they were still asleep and was fired up. So
get out of bed.
Part 2, why do I look like a bum? Well, the simple answer is it's just too hot down here. Yeah, I luckily, working as an engineer, you have a little bit of freedom as far as what you dress like, mostly. The larger the company you work for, the more you're probably required to dress up. And there are days, we had a few investors earlier this week, so I was wearing nice shirts, and I never have to wear a tie, which is nice. Sometimes it's fun to dress up, but I personally prefer comfort. So working as an engineer is normally a nice way to go if you want to be comfortable on a hot day and wear shorts. I feel bad for these guys wearing their collared shirts every day in this heat, but
You used to
good for
dress so
you.
nice as an instructor. You used to wear like dress shirt and like dress pants and like dress shoes.
I did try back then.
I don't know who told you to do that, but yeah.
And then what was part A of question 3? My reflections from 2015. You know, honestly, I think the biggest thing for me about BlueStamp was seeing students ranging from your freshman year to your senior year in high school coming in and spending 6 weeks working on projects that I could have seen passing for kind of semester-long projects for juniors in college. You know, there's a few students I remember. One guy built a self-balancing robot, which is like a common college project that you'll see people working on. For me, it's amazing to see you guys taking the time out of your summers and coming in here and learning, you know, continuing your education, and not only that, but you're doing it in a really cool way. And for the most part, you're getting to experience a lot of different areas of engineering. The reason I got involved with BlueStamp in the first place is because it's a program I wish I had access to when I was your age. I graduated high school with no clue of what I wanted to do. Had gotten into a number of schools, ended up going and taking a gap year, living in Belgium for a year, getting some cultural experience, and then committing to doing, which is also a great idea if you need a little time and want to explore the world, which I'm all about. But ended up still going into Berkeley as an undeclared engineer. It took me 2 years at Berkeley before I even picked a major because they made me, which ended up being mechanical engineering. I think if I could go back, I would have just done a general engineering degree because there's so many areas that do interest me as far as software, electrical, industrial. There's really, you know, a lot out there, and it's kind of fun when you're always learning. So I would recommend for you guys to get involved with your projects as you can, go the extra steps, find out what really interests you so you can get an idea as far as what you want to work on in the future, what you want to become. But also realize you've got a lot of opportunities to change. I mean, I'm constantly adapting in the roles that I have at work, and everyone else that I've spoken to is almost as well. It helps to focus in, it helps you get jobs, but I think the fun isn't always learning, and it's fun to adapt and kind of keep changing on what you're working on. That's about it.
Cool. I'm done now.
Awesome. Well, thank you guys for having me. I will leave an email right on the board, maybe. And you guys are welcome to shoot me further questions, ask the things you were too shy to. But yeah, I appreciate you guys bringing me in, and best of luck with BlueStamp.
One more round of applause.